Hey everybody. So I figured I'd do a little bit on scanning. It's not a subject that I've covered before, and so I've got a scanning test set up here. I'm using this microcontroller and various things to generate the binary sequences for the 858 PLL in here. That's in an adapter. We've got a cable going between these boards, and this is basically counting. Well, it's in its simplest form, it's just counting. And we're just toggling, going through the various channels. Right now it's somewhere in 10 meters. And now it's below channel 1, and it's eventually going to go up through CB, which it just is now. It's in the 40 channels, and now it's above 40 again, and just keeps cycling round and around and around. There's nothing really going on right now, so that's why it's just scanning. The squelch is closed. If we open the squelch, it'll stop scanning. If we close it again, it will start again. So what's going on here? Basically, what we don't have the squelch quite high enough. What's going on here is I'm telling the PLL what channel to go to, what frequency through this cable. PLL's making that change. Receiver, of course, then does its thing. Everything's receiving. If there's a signal present, there's some things going on in the AGC in the squelch circuit to open the squelch. If there's something present, obviously. If there's nothing present, then the squelch doesn't open. The scanning isn't a function of the radio. The scanning is a function of this. So this cable here is tied into one of the squelch amplifiers. And so when this transistor turns on, when the squelch is closed, because it is right now, a transistor is turned on and thus mutes the audio. But I'm also turning on a transistor on my end, which has a very basic Zener power supply, which is really what that forms. It's a resistor and a Zener diode, and that's just to keep the voltage from exceeding 5 volts. It's a 5 volt Zener, which then feeds the base of a transistor, thus turning it on. It of course turns it on hard, pulls the GPIO down, and the GPIs are pulled in the code. And when the GPI goes high again, it knows, well, the squelch is open and it stops scanning. So if I open the squelch, it's just going to stop wherever it is. And that happens to be, of course, channel 36. And so that's 19. There's nothing going on. Check the Super Bowl. Of course, the Super Bowl's quiet. It's fairly late tonight, so there's really nothing going on. We'll just close the squelch, let it scan. So that's basically what's going on. Now, the timing of all of this it's kind of important, and the reason for that is obviously we need time for the PLL to lock, and that's really on the best guess that I've got is microseconds. It happens so fast that the PLL is really of no consequence. The timing issue comes from the actual RC time constant that exists in the AGC and the squelch circuit, because we've got some resistors and capacitors in here that form RC time constants that delay things a little bit. And so when a signal's received, the AGC, of course, has to respond to it. The squelch amps have to respond to it. And they open the squelch fairly quickly. If I had to say it's a few milliseconds, it's probably about a few milliseconds. So there is a delay in opening the squelch, which means I have to delay here when I'm scanning. So when we stop, we have to, every time we send a pattern, when we're scanning, we have to pause. And pause for, I'm pausing for 20 milliseconds. Let things settle down. Maybe it's less. I can't recall. Settle down. Make sure that we haven't changed state on the squelch. And if not, go to the next channel. And so on and so forth. When the squelch opens, there's no timing going on in here at all, because the timing is in the radio at that point. So the time between the squelch when it opens and the signal goes away and the squelch closes again is another thing that's controlled by this RC time constant in here. You could get creative and go in here and start changing the cap and resistor value to shorten it. but it's fine the way it is. So when I open the squelch and I close it again, you know, it's fairly instantaneous. But if I was to put a signal there, which I'm going to do now, so I'll turn the volume down because it'll probably be loud. So I've got on channel 20, I've got a signal generator, you know, with a tone, and we're coming up on channel 20 now. It'll stop, and there's our tone. When I take away the tone, you'll hear static. Okay, that's the time constant. Still having the holding the squelch open for a certain amount of time happens very quickly. So we'll just you can hear that the static came and then it went away. That's the RC time constant delaying the squelch close. That's happens here. The delay between channel change and checking the squelch happens here. So there's some complicated relationship between the two delays. This one's a software delay, this one's a hardware delay, basically. And they have to work in conjunction with each other for it to sort of work properly. So, you know, I've never covered it before, and that's basically it in a nutshell. And I'm not really good at explaining things, so if you have questions, don't feel free to ask. And maybe I can explain it a little better. Probably some other, you know, minds out there will also help out if there's some question about how that really works and why the delay for the squelch is there and all that kind of wonderful stuff. But that's getting into RC time constant circuits, and that's probably something that you could just Google and better explanations on the internet as to how that really works. So anyways, that's basically scanning for dummies on CB radios. Well, retrofitting something to scan into to create a scanner for a CB. This is basically what I'm doing now. I've got a scanner for a CB going on here. So anyways, I hope it was interesting. Hope you enjoyed. So till next time.